So now we're going to go on to doing motion with algebra. It's much easier than doing. So there are two algebraic equations that are only going off based off of logic, and then we can manipulate those two to form three new equations. The five equations overall, I've nicknamed these SUVAT equations, though officially they are just known as the linear motion equations. So I'm going to be going through the proofs of all five in this video. I'm going to do them nice and slowly just to make sure you understand where each one is coming from. So the first one comes from the fact that acceleration is the change in velocity over time. So we're going to have our initial velocity denoted as u and final velocity as v. So it goes from an initial velocity u at some time t to a final velocity v at some other time t, where the time for v is greater than the time for u for a positive acceleration. So a is just v minus u over t. We're going to take that when t is 0, our initial velocity is just u to make things a bit simpler. So in multiplying by t and adding u, we get our first equation, which is v equals u plus at, or in English, the final velocity is the initial velocity plus the product of the acceleration and time taken. So there's the first equation. The next equation comes from simple distance, speed, and time. So we know that distance is velocity times time. So our average speed is just the average of the velocity. So u plus v, half of u plus v. So we're just taking the average value of the speed throughout the journey. Considering the acceleration of any particle in this case is uniform, so it's not going to jolt to accelerate quicker, this is true. So in putting this into the top equation, we get that our displacement is half of u plus v times t. So that's just putting this equation back into here and changing it to s because it's now displacement. The third equation relies on a bit of substitution. So we go back to equation 2, which is the half u plus v over 2 times t. We also know that v is u plus at. So originally when we had s as a half of u plus v times t, we just changed v in this equation for u plus at. So doing that, we get a half of u plus our v, which is u plus at, times t. Now, grouping these, we get u plus u is 2u, so that'd be a half of 2ut plus at squared. That's also multiplying t in as well. If you want more intermittent steps, that'd be s is a half of 2u plus at times t. And then distributing the t inwards gets you to here. And then applying the half, we get one of the most common linear motion equations you'll ever see, and that's s equals ut plus a half at squared. If you've done any bit of calculus and you'd like to have a go deriving this equation, it is possible, and it is not too difficult if you're familiar with calculus, so I recommend you have a go with it if you're comfortable with calculus. The next equation isn't one that we'll actually see a whole lot. If we go to equation 1, which is v is u plus at, and then subtract at from both sides, that's how we get this expression. So we put this expression into s equals a half u plus v times t, and we get s is a half v minus at plus v times t. Distributing it inwards, we get a half of 2v minus at times t. And then multiplying everything by the t and moving a half in, we get s is vt minus a half at squared. Now, and to keep saying this is not an equation you'll come across a lot. So if you forget this one, it's not much of a biggie. You usually get the initial velocity anyway. So there's really no point in using a formula that doesn't have it. but it's still at least a bit handy to know that it exists. Now the last equation I find is the trickiest, or the most finicky to derive, and that's v squared is u squared plus 2as, which is this one down here. The way we derive it is we go from v equals u plus at. We subtract u and divide by a to get v minus u over a. And we substitute that into s equals a half u plus v times t again. So the t substitute for this. Now I read it as v plus the u for a specific reason. If you know the difference of squares identity, it should be screaming at you why this is true. Distributing the half in as well, this would read s is v squared minus u squared over 2a. But if you multiply by 2a, you also get to here. And then just adding u squared, we get v squared is u squared plus 2as. And that's our fifth equation. So just as a summary for the linear motion equations, v equals u plus at. S is 1/2 u plus v times t. S equals ut plus a half at squared. S equals vt minus a half at squared. And v squared equals u squared plus 2as.